Hello everyone and welcome to Geeks for Geeks School. In today's video, we are going to discuss recursion, which is a topic of ICSE Semester 2 examination. In this class, we are going to discuss a lot of things which includes what a recursion is, what are advantages and disadvantages of having a recursive solution over our iterative solution. Also, we are going to discuss how we can use stack in place of recursion in iterative approach and a lot more things. Okay, so let's just quickly start the class and we'll see a lot of things here. Okay, the first thing over here is what is recursion. So as you can see on the screen, the process in which a function calls itself directly or indirectly is called recursion, and the corresponding function is called as recursive function. So here there are few words that you have to observe very carefully. That is, a function calls itself directly or indirectly. That means whenever we are creating a function 1, and inside the body of function 1, if I am not calling this, I am calling function 2. Okay, and at different place I have another function 2, and inside the body of function 2 I am calling function 1. Okay, now I will ask if this is a recursion. Yes, it is a recursion. Why? Because in function 2 we are calling function, in function 1 we are calling function 2, and in function 2 we are calling function 1. So basically this is another type of recursion, which is indirect recursion. So the main motive of explaining this was that if you see something like this, that means it is a recursion only, because I know that you mostly see when you see a function like this, and inside this you call that function, then you consider this is a recursive function. But this was just to explain you that this is also called as a recursive function. Okay, now and the function which calls itself directly or indirectly is called recursion. The process is called recursion, and that corresponding function is called recursive function. Okay, cool. So I hope that this is clear. Now let's move to the next thing. Next thing is, using recursive algorithms, certain problems can be solved quite easily. So basically, how is it possible? Sometimes we are not able to think about the iterative approach of a question. Whenever we are given a question, it's very difficult for us to think of an iterative approach to solve that question. Okay, so recursive approach helps us to solve that question much more easily. And there are many times, I hope that you guys have heard about a little bit of dynamic programming. So that is just improvising a recursive call. So when we write recursive functions, so what we can do is also we can use a dynamic programming approach, in which we do some changes, and we also write the iterative. Sometimes we also write the iterative approach of the question to solve the question. Okay, so basically what the whole thing is that whenever it's very difficult for you to write the iterative approach, then what you can do is you can think about a recursive approach, if that can be solved in the recursive approach. And once you have written the code for the recursive approach, you can easily convert that into an iterative approach. Okay, so that was the idea behind this. Now let's see the next thing. What is the base condition in recursion? You must have heard a lot of times like base condition recursion, right? The base condition of this recursive function and all of that. So let me tell you what a base condition is. In recursive program, the solution to the base case is provided. So what happens in recursive function is basically we call the same function in which we are. Let's just talk about the direct recursion. So what happens is we do the function call, same function call, and what are the changes that we do? We decrease the size of the problem. For example, if I want to calculate the factorial of 10, my next call will be calculating the factorial of 9, and in the function, then the next call will be to calculate the factorial of 8. So at each and every step, the size of the problem is reducing, right? But the condition where we have a solution to the problem, for example, what is the factorial of 0? If I'll ask you what is the factorial of 0, you will say 1. If I'll ask what is the factorial of 1, you will say 1. So these two are the base condition, that factorial, if n is equals to 0 or n equals to 1, then you have to return 1. So this condition is the base condition where you are returning the answer, where the next recursive calls are ending. Okay, so The base case is provided and the solution of the bigger problem is expressed in the term of smaller problem. So as I explained you that whenever you want to calculate the factorial of 10, you are going to break it like this. At each and every step you are going to calculate a factorial of a number less than the existing problem, and that's how you are going to multiply each and every answer, the answer that you will be getting from that fact function, and the base condition will be that if n is equals to 0 or n equals to 1, then you have to return 1 because factorial of 0 and 1 is 1. Okay, you can see the example over here that I just explained, that this is n, and for example just assume that I want to calculate, let's just assume that this n is equals to 10. Okay, now when this n is equals to 10, let me just write it properly. Let's just assume that this n equals to 10. Okay, now when I want to calculate the factorial of 10, what I'm going to do is I'm going to come inside this function and I'm going to check. So n is not less than equal to 1. So what happens is I'll go in this else statement, and what this else statement is saying that 10 into factorial of, like I'll again call this function fact of n minus 1, that is fact of 9. Okay, so what is happening, basically we are dividing the problem. I'm saying that this function just go and find the factorial of 9, and once you will be able to find the factorial of 9, I will multiply it by 10 and I will get my answer. So if I'll use this approach, this will get a quite bigger. So let me do one thing, let me just make it a little smaller. Okay, let's just take a smaller example. Let's take an example of 5. Okay, so what will happen over here is I will calculate the factorial of 5. To calculate the factorial of 5, I'll come to this line and I will say 5, I will write, and I will say that just go and find the factorial of 4. So I will call the fact 4. Okay, now this function will be called again. Now the n value is 4. Now this time the n value is not 5, it is 4. Okay, again I will go in this and it will say this fact 4. Inside this fact 4, this fact 4 will say, okay, 4 into find factorial of 3, fact 3. Okay, now again I am calling this function, and now the value of n is 3. Okay, now again this function will say, okay, what I will do is 3 into fact 2. Okay, now again the value of this is changed. This will be 2 into fact of 1, and when you will make this value 1, when I will come over here, if n is less than equal to 1, so here n is equals to 1. So from here I am going to return 1. So this will get 1. So the value at this place, let me just change the color. The value at this place will get 1. Okay. Okay. This will now replace by 1. So 2 into 1 is 2. So now this function, the value of this function is 2. Okay. So 3 into 2 is 6. The value of this function is 6. 4 into 6 is 24. Okay. So the value of this function is 24. And 5 into 24 is 20. 0 यहाँ पे 2 carry, and 5 to the 10, 120. Okay, so that's how we basically use our recursive approach to find the factorial of 5. I hope that this thing is clear to all of you, and we'll move to the next question. And I would just want to say that if you have any doubt while I teach all these things, what you can do is you can just ask your doubts on Discord channel. The link of the Discord channel will be in the description box. To please go and check the Discord channel and please join us over there. And if you have any doubts, then ask us over there only. Okay. Now, the next thing is how a particular problem is solved using recursion. We are going to see this now. So the idea is to represent a problem in terms of one or more smaller problems. So that's the way what we did was we broke the factorial problem into smaller problems. I said that okay, just go and get the factorial of I just ordered the function, just go and get the factorial of 4 and I will multiply the answer that you will return me. Okay, so that's how I am breaking the problem into smaller parts, right? So that is what will be the idea of understanding that, okay, in this question I will have to use a recursive approach and add one or more base conditions, and always the base condition is always important. There will be a point where you will always have an answer. So for example, if I'll say what is the e raised to the power 1, okay, you will always, or I'll say what is the value of e raised to the power 0. So e raised to the power 0 is 1. So the if I have any function that will want to calculate the exponential, I can always break it into a smaller problems, and I can say that when the value of n will be 0, if I want to calculate e raised to the power n, so what I'll say is when n will be 0, the value will be 1, right? So that will be the base condition. For each and every question, there will be one base condition at least, okay? The next thing is, for example, we compute factorial n if we know factorial of n minus 1. So as I have already explained you that when we know the factorial of n minus 1, we can calculate the factorial of n by only multiplying n to the factorial of n minus 1, right? The base case of factorial would be n is equal to 0. Here we can have two base case basically, n equal to 0, then also we can return 1, n equal to 1, then also we can return 1, okay? We return 1 when n equal to 0, okay? Now let's move to the next thing. Why stack overflow error occurs in recursion? Whenever you have written the solution for whenever you have written a recursive solution for any problem, this error is something that many of the students has faced whenever they have written the solution, right? So let's see why this error occurs. So basically, if the base case is not reached, for example, if you have forgotten to write the base case, or if you have written the wrong base case, then you will there will be no function who will be returning the value. You remember the structure that I created? Fact of 1 was returning a value 1. So there will be no end point to the function call, right? The function call will go on and on and on. And if I would have not written that condition that if n is less than equal to 0, less than equal to 1, return 1. If I would have not written that one condition, then what would have happened? Fact of 1 would have called fact of 0, then fact of minus 1, minus 2, and this will go on and on till minus infinity, okay? It will never stop. But and what happens in memory is, basically in memories what happens is that, just assume that this is memory works on stack only. So this is our memory stack, and this is the main function, okay? This is the main function. In this we have called a recursive function. So this will be our first recursive call. Just assume that f is a recursive function, and this recursive call will keep on happening. There will be no end to this recursive call. So there will be one point when this whole stack will be full, okay? There will be one point when this whole stack will be filled. Now after this recursive call, when I again want to have a recursive call, there is no space left in the stack, right? So at that time, and if you know a little bit about stack, you know that when a stack is full and we want to insert something in that stack, what error do we get? Can anyone answer this thing in the comment section? Please pause the video and answer this in the comment section if you know that if the stack is full and if you want to insert something in that stack, then which error do we get? So the answer in this is we get stack overflow error in that case, okay? So that's basically about the error. Now let's move to the next thing. What is the difference between direct and indirect recursion? So I already explained you with the example in the very starting, but let's just again see the example, okay? A function fun is called direct recursive function. Let's see when a function fun is called direct recursive function. If it calls the same function, whenever a function is calling itself in its body, then it is a direct recursion. Let's see what is indirect. A function fun is called indirect recursive if it's called another function. If fun1 is calling fun2 and fun2 is again calling fun1, if this kind of things is happening, basically one function is calling another function in its body and that another function is calling the first function in its body, then it is an indirect recursion, okay? In the next slide, let's just see the example. So as you can see over here, this is a direct recursion. In this we have direct recursion fun. Okay, let me just also get this. Okay, now I'll explain. So this is our function fun, okay, and we have some code, and inside this body we are calling this function again, right? We are calling this function again. So this is a direct recursion. Now in this example you can see we have one function fun1 and we have another function fun2, right? Now fun1 is calling fun2 in its body and fun2 is calling fun1 in its body. So this function is calling this function, okay, and this function is calling this function. So indirect recursion is happening over here, okay. I hope that this thing is clear. Now let's just move to the next slide. Okay, the next thing, what are the disadvantages of recursive programming over iterative programming? So that both recursive and iterative programming have the same problem solving power. So whenever we have a recursive approach of solving a question or iterative approach of solving a question, both of them have same power. That is, every recursive program can be written in iterative and vice versa is also true. So you have to understand that every recursive program can also be written as an iterative program, but the only thing is that there are some programs when we want to write it in an iterative approach, it gets very difficult and very messy, and it just kind of becomes irritating and we are not able to understand the logic. So that's why in that case we consider a recursive approach much more better than the iterative approach, okay. The recursive program has greater space requirement. Now why, if anyone knows why this recursive program has great space requirement, just please pause over here and comment down in the chat section, or you can say in the comment section, why do you think this is possible. So has greater space requirements than iterative program, as all the functions will remain in the stack until the base case is reached. So as you saw in the example of fact 5, I called from fact 5, I called fact 4, from fact 4 I called fact 3, from fact 3 I called fact 2, from fact 2 fact 1, then fact 1 returned the answer. Till the time we reached the base case, all the functions were in the memory stack, right? So it's acquiring some space in the memory stack. That's why the space requirement is more, okay. It also has great time requirement because of the function calls and the returns overhead. So obviously whenever we are making function call, a new memory is getting allocated and the function is creating all its frame over there, and then it is returning the value, and so all of this will basically increase the time of our whole program. So that's why the time requirements is also more, okay. Now let's see what are the advantages of recursive programming over iterative programming. So recursion provides a clean and simple way to write the code. Some problems are inherently recursive, like tree traversal, Tower of Hanoi. Now if you know about these two problems, that is tree traversal or Tower of Hanoi, so you can understand that how much a recursion is easy and simpler in case of some problems. So what you can do is you can just go and see these the solution of these two problems in First Step to DSA playlist, okay, and there you can see how I solve these two things using recursion, and you can try and write the code using iterative approach. Then at that time you will understand how much it is difficult to write the solution of certain problems in iterative way, okay. So there are some problems in which recursive code is clean and easy to understand. That's why we prefer recursion in that case over iterative approach, okay. The next thing is, for such problems it is preferred to write recursive code. We can write such codes also iteratively with the help of stack data structure. So what you can do is you can use a stack data structure in that case. Just like the memory is using stack data structure, what we can do is we can create our own stack data structure, and we can use that stack data structure, okay, to find the answer to these problems, okay, iteratively. Okay, so yeah, that's it from my side. I hope that you have understood whatever I wanted to explain about recursion. If you have any doubts, please write down to me on our Discord channel. The link of the Discord channel is given in the description box. Also, we are going to post daily polls and also daily problems on our Discord channel. So if you want to increase your coding skills, improve your coding skills, and make yourself a good coder, then please join on the Discord channel. And that's it from my side, and I'll see you next time. Before also you can just like the video if you like the content, and subscribe to our channel and share it to the people you think that they will need this kind of content. And I'll see you next time. Till then, take care. Bye bye everyone.